In an AC series circuit, resistors, inductors, and capacitors can be connected to form a complex circuit. Since each device has its own impedance, total impedance can be also calculated. The total impedance in an AC series circuit is calculated through the summation of all the impedances of each device.
The example below asks to calculate the total impedance of the circuit, to calculate the current, and to calculate the voltage over the inductor. To solve question 1, we must find the reactance of each component in the circuit. To find the reactance for the inductor and capacitor, we use the formulas above. For the inductor, the reactance is 31.4 ohms, for the capacitor it is 10.61 ohms, and for the resistor it is 4 ohms. To find the total impedance of the whole total circuit, we must add these all together using complex numbers. Using complex numbers, we find the result is 21.7 and the angle is 79 degrees. For the second question, we must find the total current of the circuit using V equals IR. So we know that voltage is 20 at 0 degrees and the resistance is 21.7 and 79 degrees. Using the polar division formula, we find that the current is 0.91 amps and minus 79 degrees. For question C, we must find the voltage across the inductor using V equals IR. Through the working out shown above, we find that the voltage across the inductor is 28.28 with 11 degrees.
Total impedance in a parallel circuit is calculated through the summation of 1 ohm impedance. This equates to the total impedance being 1 ohm total impedance. This is shown in the diagram above.
Example 2. We must find the total impedance, the current, and the voltage across the circuit below. Question A. To find the total impedance of the circuit, we must first add up the parallel components. Shown above, we add up the parallel components to get a result of 30.87 with minus 90 degrees. Then we add the 4 ohm resistor, which gives us a total impedance of 4 minus 30.87. For question B, we need to find the total current of the circuit. Since we already know the voltage and the resistance of the circuit, using polar division, we find that the current is 0.64 with 82.6 degrees. For C, we must find the voltage across the inductor. To this, we must find the voltage drop across the resistor first, using polar multiplication, which gives us a result of 2.56 with the angle of 82.6 degrees. We must then minus the voltage drop from the power source, which gives us a voltage of 19.77 to the angle of 7.38 degrees, which gives us a total result